getting more pro every day. I wonder how this will sound. I'm just running some compression and a noise filter on the microphone, so let's see how this goes. Guess what I found? This Wi-Fi module, this thing that I thought was just a Wi-Fi module, this is actually the processor that controls everything. I thought something I should have checked before is, here's the key button, because we've got, ground, this goes up to the button on the side, and I thought, well, where does the key pin actually go? I made a stupid assumption that the chip up here is a little microcontroller, and was doing the guts of the business because, and with probably good reason, the 3 pins up the side here go to the motor control, so motor on, and the laser on, and that's actually laser voltage supply. So there's a separate on-off for the voltage to the laser regulator, but there's also an enable pin that comes from this IC as well. So because of that, I just made an assumption. Turns out this is the control for everything. This is actually a Bluetooth Wi-Fi module with a 32-bit micro on there that can run some whatever code you need for IoT devices and so forth. So that's pretty cool. So that said, I traced out a few other things. I found out that module controls the three transistors. I put a blue dot next to there. They are our RGB projector diodes. So these are controlling the brightness of each one in order to enable them, disable them, etc. Bring them up and down. Through this IC, pin 2 is a PWM dimming pin. So that's what they do. This transistor turns on the motor and has speed control. So that's PWM controlled as well. This one goes to our laser diode module. That goes to the enable pin of the laser module, which can be PWM again for laser brightness. So having figured that out, I found that this trace that comes from here to pin 2 of this unidentified IC, that comes from our laser diode enable signal. So I just jumped that signal to here, because this pin is the output of this IC to the laser enable. Because this IC appears to have 3 inputs, possibly the last one's not used, and 3 outputs. This signal here, this comes from our motor. This comes from our motor drive transistor, and this is the output to the motor drive MOSFET. So I just jumped that over to enable the MOSFET for the motor drive. And this pin goes to the, this transistor, which actually, when turned on, feeds 5 volt to the laser diode regulator, the main supply. So not only can they turn off the supply to that regulator, they also control the enable pin. So I'm not sure why they would do that and why they would not want, maybe as a fail-safe, because, you don't want lasers if they happen to be on, or maybe it's supposed to turn off with the rotation feature. I'm not too sure what the goal is, because it's a bit funny in the software. So I've permanently wired that on. I suppose being always on, if there was accidental enabling on the regulator, or if the regulator faulted and left it always on, I suppose there's the potential of lasers in someone's eyes. So that's probably just a fail safety feature to be able to turn off the regulator completely, so that can't happen. At the moment, it's always on. So I've looked for ICs that might do this, things like buffers, inverting Schmidt buffers or something like that. I can't find anything in an like an SOIC8 package that has VCC and VSS, so you got your voltage plus and minus ground over here, that has 3 inputs on those pins and 3 outputs. I can't find anything that lines up, because most manufacturers will put your 5 volts here and ground in the opposite, or sorry, your V plus this corner and ground in the opposite. They're always opposite corners. So really struggling to find out what that IC is, but at the end of the day, it ultimately doesn't matter. The only weird effect I'm getting as a result of bypassing it and just jumping the motor controller directly is that this seems to have to be inverted, because on the software, the speed controller at the lowest setting is full speed and the highest setting is the lowest speed. So, but that doesn't make sense for the other pin, because the brightness does work correctly. So this one should not be inverted. So what kind of IC would take a signal in and invert it out there, but not out here? And how does this pin tie into anything? There's a third pin that's not used. So what logic tells this to turn on only perhaps when there's drive, when there's enable signal? That would make sense. If there's enable signal, pass that through and also turn this on fully. I actually had it backwards, and I PWM'd the supply rail to that regulator, so I was getting a funny oscillation off the supply coil, but it still worked and always had the enable on. But now I've switched it back. That's what it should be now. But yeah, if you could, if you had any idea what sort of IC that might be, we could do maybe a proper fix. But at the meantime, that works. We just don't have green. So I can order one of these ICs or something similar, and we can make green work again. I tried to parallel with another color, but that didn't work. I might need to change the reference resistor value for that. In the meantime, our blue and red work. Let me give you a demonstration. So it's always rotating. They can't be turned off, although I think it should be able to be turned off, so I'm not too sure what's going on there. If I turn on the laser, we can see that, and I can turn down the brightness of the laser as well and turn it up. Now if I go to the color side of things, funny enough, I might just turn off the laser so we can get a better look at that. But if I go more blue, see, it's like there's always red, and I don't know if that's supposed to be that way or not. But I've got, quite a color spectrum in the app itself. You can see you can choose around that wheel of color. I can go more red. So if I go around to the red section, it does remove the blue. If I go up to the green section, of course there is no green to come on. If I head back around toward blue, then blue comes on, and if I go all blue, it's like very little change. It does dim the blue as you head around more red. So the dimming side of stuff is working. Of course, not having any green. I think if I change the brightness slider, it's only affecting blue. Makes me wonder if maybe the IC for the red got damaged as well. Not completely, but perhaps it's ignoring the dimming signal. Something to look at, I suppose. But anyway, that's it. That seems to be going, and I just need to figure out what that other IC is. So I'd love to hear your thoughts. If you've maybe you're in the industry more and will know right off the bat what sort of 8-pin IC has 3 inputs and 3 outputs and 1 inverted. Maybe it was a little micro running basic code just to do that. So anyway, there's your follow-up. Thanks for watching, and catch you all in the next one.